Another part is copper B center. So copper B center has 3 coordination, so 3 with n-histidine, and it is present in copper 2 form, and this is copper B. So heme A3 and copper B with bind to dioxygen, and the electron transfer will occur from copper A to heme A. So now this is along this plane, that heme A, and the heme A3 is along the perpendicular plane, like this. So they are not in the same plane, and the dihedral angle, so this is the dihedral angle, is basically 104 degree. Okay, and the distance between copper A and heme A is almost around 19 angstrom. So electron transfer occurs from copper A to heme A, electron transfer, then it gets transferred to the heme A3 copper B, where the O2 also binds and giving rise to 2H2O. Okay, and in the meantime what happens, 2H plus just go out of the membrane. So if it is matrix and this is intermembrane, then the mobilization of proton takes place during the course of the reaction. So this is a schematic diagram of where the copper A is transferring the electron to heme A, and which is eventually transferring the electron to heme A3 copper B center. So this copper A is subunit 2, and the whole part, this part, is subunit 1. So now let's understand what is going on in that copper B heme A3. So copper heme A3 copper B. So heme A3, in heme A3 iron is present at iron 3 along with that porphyrin complex, like this, and 1 n-histidine, and copper B with 3 n-histidine. So iron is present in iron 3 and copper is present in copper 2 oxidation state. So first electron will come and will reduce that copper center first. So iron will remain as iron 3 and copper now becomes plus 1 oxidation state, so 3 n-histidine moiety. So this is copper B. Another one electron will come and now it will reduce the iron center. So iron will be now present as iron 2 bounded with porphyrin, and copper is present in copper 1 with 3 n-histidine groups, so copper B. Okay, now what will happen, O2 will come. Okay, so O2 will bind to the iron center like this one, and it is bounded with porphyrin plus 2 oxygen state and copper in plus 1 oxygen state with 3 n-histidine. Okay, then what will happen, that O will drag electron from iron and the oxidation of iron will take place. So the iron 3 will form bounded with iron porphyrin ligand, and that part OO minus. Okay, and it will coordinate with that copper B, and if it coordinates with copper B, copper will be having the oxygen state 2, and then the proton transfer takes place, 2H plus and 1 electron, and this part will get protonated. So iron 3 bond O bond OH copper 2. Now what will happen, this bond will cleave and we will be getting a iron oxide, and the increment will be there in the oxygen state of the iron. So iron 4 double bond O 2 minus, and copper 3 N histidine 2 and 1 OH, and again that H plus, another H plus was present, so it will form iron OH, right? So 3 and porphyrin and copper N histidine 3 2 OH, and after that what will happen, we will be getting our H2O molecule from this 2 OH and iron 3 with porphyrin and copper 2 with N histidine. That means we are getting back our deoxyform with our product water molecule from dioxygen and proton and electron. So let's understand this in a schematic diagram. So if this is the membrane, mitochondrial, and inside it all the reaction is taking place. So at first there will be a copper A center, right? Then there will be a heme A. After that the electron will be transformed to heme A3 and copper B. So the electron first gets into it to cytochrome C, then it went to the copper A, the dimetallic system. It will give, so one electron, it will give the electron to heme A, and heme A will give the electron to heme A3 copper B, and in copper B the O2 is also activating, and we are getting O2 plus H plus H2O half to H plus. Okay, and in the meantime what happened, as I discussed earlier, 2 proton goes out of the membrane like this. So it is mobilizing of proton. So what does that signify? So what is happening due to the mobilizing of proton through the membrane, transmembrane part? So the proton is mobilizing without any counter ion like Cl minus or anything. The anion is not present there. So it will the mobilization of proton, it will create a electric or charge potential around the membrane, charge potential around the membrane, and due to that charge potential there will be a difference in free energy, right? Difference in free energy. And with that free energy itself there is an enzyme called ATP synthase, which utilizes that difference in free energy in order to synthesize, in order to convert ATP to ATP. So ATP plus Pi, it will get converted to ATP, and that free energy change which happens due to the mobilization of proton across the membrane is called PMF. That means proton motive force. Proton motive force. So this force is getting utilized in order to convert ATP to ATP, which is the source of energy. Phosphorylation is taking place basically for source of all energy in biological system. So without this protein motive force, the conversion of ATP to ATP will not take place by ATP synthesis. So the cytochrome C oxidase is not only converting the dioxygen to the water molecule, is also helping to